thank you. I'm Timo Rasanen from Nokia, and I'm here to give you a presentation on the open source network monitoring setup that we have used to monitor our private cloud network. And the agenda for today is that first explain the components that are used in this solution and explain the end-to-end process from data collection from the devices onwards to the actual cloud. And in the end, I'll also demo this setup. So benefits of these solutions are pretty clear as on any open source solution. So it's license free, it is horizontally scalable and highly performant, and it has very easy to customize this based on your needs. And as all of these modern time series databases, they have very good analytics functionalities.
But does it mean, because I think it's on the TPL. I think the solution is on the TPL, not license free.
It depends on the setup.
Okay.
It's a lot. There's various components in this picture.
Thank you.
Yeah.
But the licenses are free of charge.
Yes. So okay. And also one benefit of this is breaking the silence between the compute and network team or whatever teams you have by using the same tool. And also the source of truth approach is that whatever devices you have in your inventory, they will be automatically added into the monitoring. Not like having a separate tool for your inventory and another one for the monitoring. And if we think about any of these network monitoring solutions, it basically consists of this kind of high-level components. So you have the inventory where you have your devices. You have the configurations which define basically what metrics do you want to collect from the devices. Then you have some sort of components that collects the actual data, for example with SNMP or GNMI. And then you have some sort of a database where you store the data, and then one tool to visualize the data that you have in the database. And in this case, the components are we use Netbox as an inventory for the devices, where we get the devices IP addresses, their device roles, and so on. And for the data collection, we use Telegraf and the configuration files defined on the as in table format. And time series database, basically, you could use pretty much any modern time series database like InfluxDB, Prometheus, and so on. And the visualization for this setup is built with Grafana. And let's start it off with Telegraf. So Telegraf is a powerful and lightweight data collection agent which is provided open source by Influx Data. And it has a plugin architecture, so it has altogether something like 255 different input plugins, but it has variety of networking related plugins like SNMP, GNMI, and so on. And also it has 59 output plugins, which means basically that where you can store the data. So pretty much all the common databases are supported there. And also it has 29 processor plugins, so that you can do some of the processing of the collected data already on the Telegraf side, on the edge, before storing the data to the database. And here's Telegraf configuration file. So it's basically a total file where you define the parameters that you want to collect and all the intervals and so on. And basically, you could run this setup like this. So you handcraft the configuration file, pass it to Telegraf. Telegraf starts collecting the data, stores it to the time series database, and then the visualization is done with the Grafana. But there are some caveats. So, of course, it's not very nice to create this kind of a large configuration files manually, and also that you need to have different configuration files based on the vendors, platforms, and device roles. So you might even have like the exact same device type, but in in a different role, and then you need to monitor different parameters possible from those devices. And a good example, for example, is that you monitor different metrics possible from firewall compared to some LAN switch. And how to manage the Telegraf config files? So then it comes with the Netbox. So Netbox is an open source data center infrastructure management and IBM tool. And in this solution, we get the documentation of the devices which should be monitored from Netbox. And Netbox has data models for other types as well, like sites, racks, device roles, platforms, IPs, contacts, and so on, which can be used for building the monitoring configuration for telephones. And the key features for this solution is, of course, data models. So we need to know the devices, models, and roles, and so on. But there's also the config context, which we basically use to build that Telegraf configuration file. Netbox also supports webhooks, so that we can notify other tools for the changes that happen in the network. So, for example, if device roles, device status change from active to offline, we can send the webhook so that it will be removed from the management. Then there's custom links, so that we can point links directly from Netbox to the graphs. So that you don't need to start finding those graphs from the Grafana, you can just click the link from Netbox. And also custom feeds, so that, for example, you could add possible information about the maintenance breaks into Netbox. And the config context looks like this. We can take a look at this in detail, but it's basically just a JSON file where you define the template for the Telegraf configuration. And this one is applied then to the actual device, and we can get the configuration from there. And then how to trigger the config generation. So for example, if we add a new device or delete the device, we can use the webhooks. So these are just like notifications when something has changed. And you can customize the payload what you want to send within the hook. And this is how the webhook configuration looks like. So it defines the models which will trigger this one, and then there's also some conditions. For example, if you want to trigger different hook based on the possible device role. And then, of course, when the webhook is sent, you need to have some code that actually receives that webhook. And in this case, it's a Python code, and it listens for the webhooks from the Netbox. And it's for example, can be written for example Python Fast API or Flask. And this one receives the webhook, renders the configuration, and also there's an optional queuing for received webhooks. So for example, if you modify 100 devices at the same time, it will send 100 hooks. So it might be smart to receive all the hooks and then process everything in one batch rather than processing them one by one. And now we would be in this phase. So we have Netbox, we have the config generation script, and then the configs are passed to Telegraf. But yeah, we want to have version control, so we add Git. So why do we need a Git? So first, version control, we want to have repeatability, scalability, and also disaster recovery. So, for example, if there would be some unintended change to Netbox, for example, that all the, let's say, device roles have changed, and it might be, depending on the case, it might be difficult to restore it back, and in the worst case, you might need to do the restoration from some backups. So it's better to have them somewhere else pre-rendered rather than rendering on the fly based on the Netbox area. And it's also possible to add some CI jobs and run some tests for the configurations if you wish. And then how to deploy the Telegraf configs. So now they would be residing somewhere in the Git repository. So there are multiple ways of deploying this configuration, but this is a pretty handy way to do it. So there's this application called heatsink that can be deployed as a sidecar application for Telegraf. And this heatsink only role is to fetch the latest changes from Git. And if there are any changes there, it will pull the latest changes and pass it to the Telegraf. So you could be doing the same thing with, for example, with Ansible or something like that, but this is pretty simple from my point of view for deployment. So it looks like this. So you would have like multiple Telegraf instances in your environment, and you have the configuration files stored centrally in the GitLab, GitHub, or whatnot, and then the heatsink sidecar would be fetching always the latest versions of those configuration files from the central source. So now we would be in this phase. So Netbox has the data. We have a config generation script which is pushed to Git, and Git soon fetches the latest configurations. And then about the database. So what is the best time series database? So from my point of view, the best one is the one that is already used in your organization, so that you don't need to do the same work twice. And the second best is that database that is managed by someone else than you. So Telegraf supports something like 59 output plugins. So most probably the database that you want to use, Telegraf always supports that one. And then about the data processing, I mentioned that there are some data processing plugins used available in Telegraf, and this comes very handy in the networking world, especially because we usually work in multi-vendor environments where the data might be in a slightly different format between the different OSs. For example, memory might be in kilobytes, megabytes, or utilization per second. So from my point of view, it's easier to normalize the data once the data is collected and then pushed to the database. Because otherwise you need to normalize it when you read it from the database. And then there's a couple of other plugins like converters, so that you can convert, for example, integers to strings to integers and vice versa. It's possible to rename the tags or fields, and deduplication, which is especially handy with if you're monitoring with SNMP, because there are some of the data that doesn't actually change that frequently. For example, software versions or system hostname, they might be constantly same number or same string, and it's possible to make it so that it doesn't actually send that data on each of the intervals. And then the last one is Starlight processor, and this is basically the processor that if there isn't any dedicated processor, you can do it with this one, because it's a dialect of Python, so you can do basically write Python code to modify to collect the data. And it has minimal impact on the performance. So even though you run some code to modify the collected metrics, it doesn't actually impact that much on the performance. So for example, in this case, this is a modification for memory values to get the percentage out from them. So it basically just divides the available memory with the total memory and multiplies it with 100, so you get the percentage. And the other one is to get the CPU utilization based on the CPU idle value. And now we will be in this phase. So there are quite many components in this setup, but hopefully I'll demo this and you'll see that it's not that complex for the users. And I added also the links to all of these components that were in this presentation and demo. And then I'll tell you a bit about the demo setup. So the whole demo setup is running on the Docker containers. So Netbox is running on the Docker Compose, and the rest of the stuff is running on the container lab. And also there are two switches in the environment, the webhook listener, Telegraf, kitchen sidecar, InfluxDB and Grafana. And they are all defined on the container lab configuration file. And let's move to the demo then. So, so I have here on the Netbox, I have here the Grafana, and this window, even though the text is small, you don't need to read the text, but that's the logs from the webhook listener. So when I make the changes on the Netbox, you can see the changes in here, that it prints out the line that webhook has been received. So the first one is here. I'll show you the devices, and I can make it larger. So Netbox basically has this information about the devices. So that, for example, this device resides on the site 1, it's in the room location 1, it's in rack 1, and so on. We have the platform defined, so it's SR limit, and we can also see the position of this device in the rack. We can see the also the interfaces here, and how these interfaces are connected to each other. So in this case, it's 4 cables connected between the 2 switches. Okay, and then I'll show you the config context. It basically looks like this. So it's a JSON file where we define what we want to monitor. And for the simplicity's sake, we are only collecting the interface metrics in this demo. And this config context has been applied on the platform level. So this will be the default configuration for all the SR Linux devices. And on the config context can be applied also based on other criteria. So in this case, we are assigning based on the tag. So whenever there's a tag like this on the device, this config context will be applied. And we can see then the config context rendered on the device level. So in this case, there's just a single one which then will be applied. And if I do it like this, we can see that we are collecting the metrics from this device on 1 minute interval. And what we're going to do here is we will modify this device. And let's make it first offline. So I change it to offline. And we can see that we received the webhook here. And now it has a 30-second delay, so it's basically waiting for if there would be other changes, so that they will be processed in the one go. And what we can see here is the GitHub page where we have these 2 different configuration files here. And now we can see that the configurations were processed and pushed to the remote. So if I refresh this one, we can see only one of those devices. And now if we would wait for a longer time, we will see that the metrics are not being received anymore in the to the Grafana. But as we don't have that much time, so let's put it back. So I will make this one active. Actually, I can do it like this, so it might be more visible for you. And what we want to do is that I'll add we were previously monitoring it on a 60-second interval. So now I'll add a tag here, so which will override the config context and change the interval to 5 seconds. And again, if I do it here, so the webhook was received, and if we take a look at the config context, we can see that there are now two different config contexts, one with the weight 1000 and the other one with the weight 3000. And of course, 3000 will override this one. So we have now the sample interval specified as 5 seconds. And now we need to wait a bit. So now config has been for the data to populate again. I can show you the other nice feature of the Netbox is the custom links. So sometimes finding the correct data from the monitoring tool can be quite painful if the data structure is not so logical. So this is a very nice feature about Netbox is that you can create these custom links that point directly to the Grafana. So based on the device name. So in this case, I just clicked link from Netbox and it takes me to the device metrics. And it's also possible, and actually we can now see that data collection interval was changed now to 5 seconds. And it's also possible that when we click on the device, it prints us basically all the interfaces, monitoring interfaces on the device. But in this case, it's also possible to add them to the single interface. So let's pick this one, and we can get the interface metrics from the monitoring interface. There's also one thing. There was previous time when I was talking about it, there was a question that whether it would be possible to add information about the maintenance breaks. So I added here a couple of custom fields that can also document the possible maintenance break and then start time. Yes, that's about it. I can also now do the now when we can see that the data has been collected now for 5 seconds interval, I can also make it back. So just by removing this tab. And now we can see that again the webhook was received and it will be processed in the background. Okay, that's all from my side.
Any questions?
I have one. Modest. What was the most challenging part? Was it to be able to get the inventory and all that stuff done, or was it actually monitoring?
I think the most challenging part has been the alerting, to get the alerting intelligence to the alerting. But we have the inventory already in Netbox, so in a sense that was kind of a easy part. And we have done it basically on these steps that we first generated the configurations on the fly and when we started the Telegraf instance. And the latest addition is that we took the version control with it.
Anything else? Well, Timo will be here all night as well. So give him a big hand. And then